Hello, friend, and welcome to another episode of Artworks for Teachers. I'm your host, Susan Riley, and today I'm thrilled to bring you Cindy Lawrence. Cindy is with MoMath. If you are not familiar with MoMath, you are going to be so excited about this episode. The Museum of Mathematics is actually located in New York City and has been around for a long, long time. And today, Cindy is going to chat with us about what the Museum of Math is and how we can use math in a lot of different ways, even if we aren't a math person. What I love about this conversation and what I want you to really think about as you're listening is that when Cindy talks about math, it's almost like listening to an artist talk about how they discovered their artistry and the evolution of their work. So when she talks about the evolution of the museum and of her favorite exhibits and of, exciting ideas around parabolas and how they use strings to light up around these parabolas, um, you're going to think like, is she an artist? And really her background is in math. And so I think what's going to be so surprising and encouraging about today's episode is how we can bring this idea of making math fun and creative into our own classrooms. So without further ado, here's Cindy. All right, well, hello, Cindy. Thank you so much for being here today.
Thank you for having me.
Of course. So let's start out by can you share a little bit about your story, how you got to where you are and like the background that you have?
Sure. So I have always loved math since the time I was in grade school. And I've always, I think, been fairly good at math and thought maybe I would have a career in math. But things didn't work out that way. I went up to a pretty high level in college, but I wasn't sure what I would do with the math that I was learning. And so I eventually went in another direction that I thought had a more assured career path. So I became a CPA, I became an MBA, but I never lost my love for mathematics. And when I had children, I really started to re-enjoy mathematics through the eyes of my children. And we would play games and do puzzles and things that really felt very akin to math to me. So that was sort of my connection back in. And it turned out my children were interested in and also good in mathematics. And so we found ourselves part of a community with other families where the children were interested in not just math, but science as well. And so we would all go to Brookhaven National Laboratory, which is sort of in our backyard, for summer science Sundays. And we would go to Cold Spring Harbor Laboratory when they had events. And I just sort of fell into this group. In particular, there's a program that was running in a local college, which is the State University of New York at Old Westbury, that was entrance by exam for gifted math students. And each of my children in turn took the test that allowed them to participate. But through that program, I met families whose kids really loved and were good in math as well. That opened my eyes as a parent to many more things that I didn't know about. There were online programs, there were programs in the Boston area. And so there was sort of this parent network that developed. And that's how I got involved with other families whose kids liked math, one of whom, the father in the family, was a mathematician who had the idea to open a museum of mathematics. That to me sounded like one of the coolest ideas I'd ever heard. And so I immediately said, let me know if you need some help. And famous last words, because I ended up volunteering for the first project that he was doing, which was to build a traveling exhibition of mathematics that would make its debut at the 2009 World Science Festival in New York City. And I ended up volunteering to spearhead the committee that would figure out what we were going to bring. And what we brought was really the precursor to the Museum of Mathematics.
Mm.
So that festival was a proof of concept. Would people like to ride on a tricycle with square wheels? Turns out they not just liked it, they loved it. That became the top exhibit in our museum. So I went from volunteering for something that sounded cool and let me get back to a topic that I'd always liked but hadn't pursued professionally, to something that became such a passion for me that ultimately I quit the job that I'd had for 18 years to throw myself full time into this.
Wow. Wow. That's amazing. So Tell us how the Museum of Math has evolved, because I've been following you guys for a long time. I mean, I'm gonna say maybe a decade, maybe more than that. Like I've been watching it for a long time and I've been so impressed with everything that you all are doing. So, and I know it's evolved a lot. So can you tell us a little bit more about the museum itself and how it's changed over time?
Great. So we started as a traveling exhibition, and that traveled the country for 5 years. And what that allowed me personally to do, and others involved with the museum as well, was everywhere that exhibition went, I would go at least once and ask for a meeting with the executive director or the head of education and just pick their brains about what works in a hands-on science center, what doesn't, what are the challenges. And so we learned a little bit about how to run a museum. We none of us had museum experience in the original organizing group. We then also, in some places where the traveling exhibit went that were more in our backyard, we asked if we could host our own event or host field trips. And so we were at the Urban Academy on the Upper East Side of Manhattan, and they allowed us to host field trips while we were there in their school. Other schools came, so we got practice with that. We got to have evening events. We had one there. We had one at the New York Hall of Science when the exhibition was there. And then we opened our own museum, and that was a very steep learning curve. One of the biggest lessons that I learned was that if one exhibit in a hands-on museum is broken, it's really fine. But if two exhibits are broken, that equates in most people's mind to everything is broken.
Mm.
And we were impacted by Hurricane Sandy, which hit in October of 2012. We were scheduled to open in December, and we weren't even allowed in our space. Trucks that had our exhibits on them were not allowed to cross the borders into New York City. And so we opened basically with exhibits that had just rolled in and hadn't really been tested in the space. So
Mhm.
we had a lot of things that broke initially that we found out weren't built in a robust fashion. So maybe one of the most important lessons we learned is if you build it, they will break it. And, my initial thought was if you build something right, it doesn't break. I learned from visiting other museums and hands-on science centers that that's actually not the right philosophy. The philosophy is figure out how it will break and engineer it so that when that breakage happens, it's not hard for you to swap out a part and get it back up and running quickly. And that's a very different philosophy than we're going to be so good that we're going to build it and nobody will be able to break it, because that's actually not possible. Or not
That's
likely.
too deep. Yeah.
So we learned a lot about customer service and about running a museum that's open 364 days a year. And what we also learned is that there's a lot of joy in math, and there's a lot of joy that we could bring to people, not just people who liked math always or loved math or are already mathematicians or scientists who use math, but the particular joy to me is being able to see a smile come across someone's face who walked in saying, I don't like math. I'm here because my kid likes math, or because I think it's a good thing for my kid to see this, or I'm here because my partner loves math, but I don't. And I also like to tell people it's very similar to going to an art museum in that most of us are not painters. We don't think we could, paint or sculpt any kind of masterpiece. But we all still go to art museums to see something beautiful and to be inspired by something that someone else created. And there is that same aesthetic beauty in mathematics, but we have to spend time teaching the mechanics in school, of course. It's like learning to play an instrument. You have to learn how to hold your instrument and how to read music, and that's not the fun part of it. In school mathematics, you don't get to the fun part until you're in college or maybe even grad school. And that's, it makes sense. There's a lot of mechanics to learn. And sometimes there is a little bit of fun that teachers instill on the side. I mean, it's wonderful, but that's certainly not the focus. The focus in a math classroom isn't to make people see the joy of a masterpiece the way, just like in an art class in school, nobody's really expecting all of the students in the class to produce masterpieces that could go into a museum, but we hope that they something catches their interest, so those who are interested might go on and become professional artists. And so in much the same way, we want people to come to the museum and have a beautiful experience and see something that they enjoy engaging with. I do not walk into the museum ever where I don't hear while I'm wandering around from some stranger that I don't know as I'm passing by 3 words. And those 3 words are, "That's so cool." And, you don't hear people say that about math or think that about math all the time. And so to me, that's the really the fun part of my job is walking into the museum and seeing people inspired by something, even if they weren't the top math student in their class, or they didn't like math, or they haven't seen math in 50 years.
Yeah.
So we transitioned from like learning how to run a museum and being novices at that to getting much better at anticipating what people will like, how they'll interact with things, really creating a sense of community where it's sort of a nexus. Anybody who likes math and science who's in the city visiting wants to stop by. And so you never know, you might run across a famous mathematician or, a child prodigy in math. But it's also a museum for people that are just the opposite of that. The other big transition for us occurred during the pandemic and as a result of the pandemic.
Yeah.
In
Okay.
early February of 2020, when there was sort of a hint and a whisper of a virus that was in China,
Mhm.
I asked my senior leadership team to think about what we would do if we had to close. Like, how would you run your department and what would you do if the museum had to shut down?
Yeah.
This was very early in February, and they all kind of were questioning, why are you asking? What are you talking about? And I said, well, I know it's a little crazy, but there's this virus, and I'm just thinking, I know it's crazy. I'm worried for nothing, but. And so I said, come back next week. We meet every week and let me know how you would run things if you had to run things from a closed museum. And the next week they came back and every person had the same answer, which was, what? You were serious? We didn't think you were serious. I said, I know, I'm crazy. You're right. I'm a worrywart, but like, yes, I'm serious. So go home again this week and really come back to me. So by the middle of February, they all came back and we had identified something called Zoom, which was something kind of new. And we had maybe used it once or twice for something, but certainly not regularly. We had identified that we would use Zoom. We looked into what it would cost to have a Zoom classroom. We were mostly thinking about field trips that were booked for the museum. Could we have a class of 30? Could we have a class of 100? How would it work? And so we actually had all of that at the ready, and I never thought we would use it as much as I had asked for it. And then things very suddenly in March kind of went south, as we all remember. And what's interesting is on Thursday, March 12th, that week, that whole week, we had schools canceling their field trips because there had been cases now in the city and schools that were coming from outside or even that were in the city were just worried about leaving the boundaries. Their school felt safe. The world did not.
Yeah.
And so a lot of schools had been canceling, but some still came. So the very last school to physically have a field trip to the museum came on March 12th. But also on March 12th, we started offering the schools that canceled earlier that week online field trips in our new Zoom room.
Yeah.
And March 12th was the first day we had an online Zoom field trip. So the same day that we had our last in person, we had our first online. And we shut down on the 13th, like everybody else in the city, but we never missed a day. Like we
Mhm.
never had a day where we said to schools, we have nothing for you.
Yeah.
So we were very lucky in that regard. And what happened then is we built an online worldwide community, people that could never come to New York. And that we ran that way for much longer than any other museum in New York City because there was, so the summer of 2020, by June, museums were allowed to open with sort of strict constraints. You had to have a single path through and limit the number of people, and everyone had to be masked. And also, you couldn't open any exhibit that required people to touch it. We all thought germs were being transmitted through touch. We didn't understand that this was primarily an airborne virus. We knew it was airborne. We had masks, but we also thought, we were washing groceries and that sort of thing. Well, pretty much all of our exhibits are hands-on things you touch. So in effect, that rule meant you could open and have people walk through, but you couldn't have people actually visit the museum. So
Yeah.
we were closed until the following summer. No other museum, I don't think, in Manhattan was closed throughout for that long. We were closed for 18 months.
Oh my gosh.
During those 18 months, we are also, I think, the only museum in Manhattan or maybe in all of New York City that did not lay off any full-time staff, did not furlough any full-time staff, did not give pay cuts to any full-time staff. We turned everybody toward this online museum that we became.
Yeah.
And that allowed us to do something really amazing, and that is to build a worldwide community. And one of the most inspirational moments I think I had during the pandemic was when we did an online game night of sorts. And we had uh, people form into teams, sometimes two-person teams. And there was a senior citizen who partnered with a child. And it was almost like a grandparent, grandchild, but they weren't related and didn't know each other. And that senior citizen wrote to me and told me that they were completely isolated. They were in their own bubble. They had no family. And that night was so meaningful, and the joy of interacting with a child.
Yeah.
And similarly, I think at the same event, we had a family come that was spread across the country that, of course, hadn't been able to see each other. So it was really meaningful and wonderful to watch communities and relationships develop. I myself made a lot of friends during this time through Zoom and through interacting with, people became quote unquote regulars. This
Yeah.
people would show up. So that was really beautiful. Then we had a little bit of a quandary when we reopened because the people from around the world said, well, we hope you're not going to desert us in our, now that you're reopening. And so we initially reopened and we said, we're going to stream everything we do on Zoom. And we did that for a while. And it is possible to do that, but it's very resource intensive.
Yeah.
And ultimately, we had to back away from that a little bit because you're either optimizing for the people in the room or you're optimizing for Zoom. It's very hard to optimize for both.
Yes.
And also, what was happening was we were really hurting our in-person event attendance because, well, you might sign up to come in person, but it's a little cold out, or I'm a little tired. I had a long day at work, and I can watch it on Zoom.
Right.
So now we'd be flying a presenter in from somewhere around the world to give a live talk, and we'd have a lot of people register, but 10 would show up.
Yeah.
Now the feeling in the room is not conducive to having a great program. It feels empty. So we walked from that. But what we do is we started running online programs that are strictly online. And so we have a series of 6 or 7 programs that run every month online, and we optimize for online. And what's nice about that is we keep our worldwide community and friendships. We can have many more different presenters come. A lot of top presenters don't have the time to fly to New York and spend a day. And so we're able to, we say, well, could you give us an hour on Zoom? We have an audience for you. So I think that was the biggest transition for us to date, except that now we have another transition coming that we're in the middle of. And that is we opened on 12/12/12. So our 12-year anniversary is actually tomorrow. Very exciting.
Wow. That is exciting.
And we loved our inaugural home, but ultimately the building was bought by a real estate developer who's turning it into luxury condos and didn't think that the luxury condo community wanted a museum of math in their building.
Mhm.
So we started the hunt for new space. It took us a little while, but we just announced actually on November 11th, we signed a lease. So we're moving to a bigger space in a more prominent location right on the corner of 6th Avenue and 19th Street.
That's great.
We are super excited about that, but we had this little gap in between the two locations. So we literally moved from 26th Street, close to the corner of 5th Avenue. We're now on 5th Avenue at the corner of 26th Street. So we literally dragged some of our things around the corner.
Yeah.
We are operating what we call MoMath on 5th, which is a temporary installation. It has some of our favorites, like the square wheel tricycle, but it also has a couple of new things. So we wanted people to come and experience something new. And then we're using this opportunity to take the bulk of our exhibits, which were 12 years old, and refresh them, refresh the technical aspects of them. They were all using 12-year-old technology, refresh the way they look, a fresh coat of paint, and just really, so when we open at Sixth Avenue in about a year to a year and a half from now, even the old favorites will have sort of will look spruced up and spiffy and operate in a way that's aligned with today's technology.
That's amazing. And there's like just hearing the evolution over this period of time, to see the amount of work that you've done, the lessons that you've learned, how you keep iterating and reiterating over time. It's fantastic to hear. And it sounds like it's just an amazing growth experience, which is, I think, fantastic, especially as coming from someone who never felt like she was good at math. I've loved following all of the work that you guys have done, just because it feels like art to me. Like the way that you present math, and I'm an artistic person, it feels like I can do this and I understand this, and it makes me more curious to learn about math, which I think is part of your mission and your vision, which is amazing. So I would love for you to share, like, what are some of your favorite unique exhibits? I love the tricycle, the riding on a square wheel tricycle. But what do you think are some of the ones that best demonstrate, the fun side of math, the creative side of math?
So I'll tell you about two favorite exhibits. Let me start with one that is very much evidence of the creative side of math. We have an exhibit that's very popular that's called PolyPaint.
Okay.
And this exhibit, one of the things that we strive for with all of our exhibits is to not have them be something that feels like something you would do on a computer at home, even if actually we could make them that way.
Mhm.
So it turns out, if you think about wallpapering your room, a wallpaper pattern, it repeats, right? We always try to line up the seams. It turns out there are only 17 different ways that you could repeat in a wallpaper pattern. The 17 symmetry groups, mathematicians would call them, which is
Okay.
itself surprising, like why 17? But setting aside the why of that, which is a pretty technically challenging thing to explain, um, there are 17 ways that you can have patterns. We created an exhibit that has a giant easel and a paintbrush and cans of paint. And then it has these 17 symmetries that you can choose from. And you literally take your paintbrush and you dip it into a color. And maybe you've selected a pattern where things repeat in threes, let's say. The minute you start painting, and you literally are taking a physical paintbrush and running it across a screen that looks like it's an easel, your strokes of paint get repeated in this symmetry that's like a trifold symmetry. And immediately the canvas fills with this. And it's automatically beautiful. It turns out that the human brain likes and appreciates symmetry. You dip your paintbrush into another can and you take another swipe, and you're filling with a different symmetry and a different color. And people love this exhibit. You are painting, but it's like painting in a very enhanced way. No matter what you do, you end up with something really interesting, really beautiful, but yet you've selected the way the pattern repeats, you've selected the color, whether your brush stroke is thick because you kind of push hard on the paintbrush, or whether you're very light and you get these very, so you really feel like you're painting, but you're painting with mathematics. And
That's
to me, it's super fun,
Yeah.
but yet there's deep math under there. If you want to look under the hood, you don't have to look under the hood. So a lot of our visitors will come, and if they're just enjoying the experience, that's great. If they see that there are different patterns that they can choose from, and just knowing that, oh, there are different patterns, and that's part of the world of mathematics, that's great. If they want to dive more deeply under the hood and read about the fact that there are only 17 and what's the math underlying that, and who are some of the mathematicians that are involved in studying symmetry, they can do that too.
Mm.
So that's one exhibit. The other one that's my favorite is an exhibit called String Product. And what I love about this exhibit is that it really appeals to preschoolers, and it really appeals to math PhDs, and it really appeals to everyone in between. in very different ways.
Mhm.
So if you look at it, it looks like a piece of art. So first of all, it's aesthetically very beautiful. It's what we call a paraboloid. A parabola is the shape you get if you throw a ball through the air and it kind of goes up and comes back down in that nice sort of arc. If you turn the arc upside down so that it's smiling, and then if you kind of spun that around really fast, it would make like a tall, narrow bowl shape. That's a
Mhm.
paraboloid. So this exhibit is a paraboloid that has electroluminescent wires strung through it. And
Wow.
those wires light up depending what the visitor does. And if nobody touches it, then the wires just light up in a sort of very artistic sort of dance that they do, I'll call it. So it's just beautiful to look at this. But the exhibit is actually about parabolas. And if you're a PhD mathematician, you will quickly look at it and realize it's demonstrating a particular mathematical property that you probably never knew. The
Mm.
fact that most math PhDs could see something that they can recognize but haven't seen before is what's fun at that level. And this happens over and over again that a mathematician comes in and says, "Oh, that's so cool. I never knew that fact about parabolas."
Yeah.
At a slightly lower level, somebody in high school or even in middle school can prove this property about parabolas pretty easily.
Mhm.
And it's a question that I ask a lot of our young staff to prove and show them how to do it. So it's nice because you don't need that much math to understand what's going on.
Yeah.
At a lower level, this exhibit actually just represents the multiplication table. And so
Mhm.
when a third grader comes up and they push a 5 and they push an 8 and they see a string light up that runs through the number 40, 5 and 8 made 40 light up. Let me try 2 and 8. Oh, 16 lights up. Let me try 5 and 7. Oh, 35 lights up. So for a child in elementary school, it's a multiplication exhibit. That's all it is. And it's one
Yeah.
where they can push two numbers and watch the product light up.
Yeah.
For an even younger kid, they're randomly pushing number buttons, but to a 4-year-old, I push a button and I made a light come on in this giant thing that I'm looking at. Like, that's cool. I'm going to push some more buttons. Oh, I made some other lights come on. And so to me, that exhibit really hits on so many different levels that it's
Mhm.
great. And you'll see a family come up with multiple generations and they're all smiling and delighted for different reasons. So
Yeah.
that one is probably my favorite exhibit in the entire museum because it's beautiful, it's artwork, it has aesthetic appeal, it has real math under it, it surprises PhD, it delights 3-year-olds. Like, it's my favorite exhibit.
There's something for everybody for sure. So one of the things that struck me that you talked about a little bit earlier, but you've also touched on it with the exhibits, is how we treat math in education versus the reality of what math really is and how you can play with it, and that it is something to be explored very similarly in that you would explore art or music in that way. So in your opinion, and based on what you've seen in the museum, how you've interacted with parents and educators, what role, how can we enhance the way that math is taught or viewed in education right now?
So let me first say that teachers have a tough road. They have to teach the basics. We want to get every child to a minimum competency level, and that takes time. And it's kind of like we wouldn't expect a violin instructor to walk in and have kids after a couple of days playing some kind of Beethoven concerto perfectly.
Right.
Right, we would expect that there's going to be months of learning how to hold the violin and how to hold the bow, and there are going to be lessons in what the 5 lines on the paper with the little circles, what does that actually mean, and how does that translate to what you're doing with the violin that's in your hand. And but yet what we do is we take kids to hear the symphony. We inspire them.
Yeah.
MoMath is meant to be the symphony of mathematics, but it
Mhm.
doesn't change the fact that the teacher still needs to teach the basics.
Yeah.
So I think our teachers do a great job, and we have a system in which there's a lot of testing, and so there are dates by which things need to be accomplished. What I wish is that there was more time in the day to inject some of the more fun sides of math, or even to inject some thinking rather than some lecturing. And what I mean by that is, I'll give you an example. When kids are learning about graphing and they're learning that you have an equation that you can draw a line on a coordinate axes, and they learn different things about points on the plane. There's a formula for the distance between 2 points, and it's really messy looking and complicated. Because
Mm.
we don't have a lot of time, we often present the formula to kids as something to memorize. And if they dutifully memorize it, they can answer the question, what is the distance between point A and point B? They just plug in the coordinates and they get the answer.
Yeah.
But actually, there's a very beautiful theorem in mathematics called the Pythagorean theorem, which is about right triangles, which itself is something that we teach kids to memorize. But actually, there's a geometric puzzle that kids can play with that teach them the Pythagorean theorem and why it's true. And it's
Mm.
it's a puzzle that involves squares and cutting them into pieces and rearranging those pieces. But most kids know the Pythagorean theorem, regardless of whether that was given to them to memorize or they got to play with the puzzle. And there's a way to use the Pythagorean theorem, which a squared plus b squared equals c squared is something that kids typically remember,
Mhm.
to get the distance between 2 points. That's actually how you derive that big, long, messy formula.
Mhm.
But a lot of times there just isn't time in the classroom to
Yeah.
show that, or better still, time to say, how could we find the distance between 2 points? Who has an idea? And
Yeah.
try to guide kids to discovering that. There is
Abs-
time. So I think we do a great job, and we try to interject where we can, and coming to a place like MoMath, and we do have online field trips as well as in person. So look for the ways where we can inspire your class to be interested and to want to know more. But yet we understand that there are limited classroom hours and there are certain minimum things that we need to teach children so that we're raising a numerate society. We want people to understand. I think most people did not understand exponential growth. And actually, the pandemic taught all of us in a very frightening way what exponential growth really looked like. Like we all could kind of imagine that, oh, that means growing quickly.
Yeah.
When you see, oh, I have COVID and I was with five of you yesterday, and then each of the five of you says, oh my God, I was with five people. And
Yes.
suddenly, we saw this. We saw one infected person in Seattle blossom into a pandemic across the nation. And we
Yeah.
would have these hot spots where you would think, oh, there's nothing in my community. Like we all had the moment, most of us had a moment of thinking, okay, where I live is okay. It hasn't gotten here. It probably won't get here. And very quickly, we saw the power of exponential growth, and it got everywhere.
Yeah, absolutely. And in a very real world way. And I think that's the beauty of what MoMath actually brings, is that it makes math, it turns it into a real world play period. Like you get to experience it in lots of different ways. So for our listeners who are interested in learning more about MoMath, or connecting with you, how can they find out all the information?
So if they go to events.momath.org, they will see all the upcoming events, many of which are online. And that's a great way to start connecting with the museum or with anybody at the museum. There's always the chat and Zoom. We try to have our events, not events where people are silent. So there's a setting in Zoom where nobody can speak and you can just listen. We don't use that setting. We very deliberately don't use that setting. We are trying to build community around mathematics. And whether it's a room full of people who are struggling with math, or a room full of people who love math, or a mixed room of all kinds of different people, we want that community and that friendship to develop. So that's a way to participate in our events. Our website is momath.org. So just reading more about the organization, what we do, our mission, different ways to engage. We do host events. We rent out our space. It's a great place to have a birthday party or a corporate event or a book launch or anything like that. We have adult only events. We have a game night where we play games all night, and the games have some kind of mathematical underpinning, but We're talking about games that everybody knows and loves as well. We have senior sessions that run online that are adults only. Of course, we have things geared for children. We have discovery sessions and sessions for gifted math students, and we have a summer camp that's very popular. People sometimes ask, what is the age range for the museum? I have a very simple answer for that. The range is 2 to 102. Literally, I think you should bring your child. I actually, at 18 months, when I have friends who have children, I say when your child turns to 18 months, that's when you want to start bringing them. Learning researchers have shown that by the time kids get to elementary school, they have already identified internally whether they are a math and science person or not.
Yep.
By and large, many young girls have already identified math and science as something that they perceive as being more for boys than for girls, which is a shame. Sometimes the first exposure a child has to math is in a classroom, like the word math. We don't usually use the word math so much in kindergarten, but when you start getting into early elementary school, there starts to be, this is the time period at which we are doing math.
Yes.
And math is very often a worksheet. In the earlier ages, yes, it's manipulatives. We love that. But at some point, it becomes worksheet and symbols. And
Yeah.
some kids are great at that. And some kids are flustered by that or don't understand it or forget the rules. And we don't want the first association with the word math to be a feeling of frustration or fear or something that just doesn't seem useful or fun.
Yeah.
So if you bring a child when they're 18 months to a place that has the word math in its name, and it's a brightly colored, fun environment that they enjoyed and they want to go back to, that's the emotional impact that we want them to feel when they hear the word math. So having the first impression be something like that, if you can, when your child is young, bring them to MoMath, I think you do them a real service in setting an attitude that hopefully will stay with them and at least keep all the doors open. Because I think what happens is kids who early on feel like they're not good at math, they close certain career doors, even though they might only be in elementary school. If they've decided I'm not a math person and they proceed through school taking the minimum amount of math they need, and then they get to university and they say, I'd really like to be an astronaut. I'd like to, go to pilot school. They're going to discover they need calculus. And oh, well, I didn't take calculus because I'm not a math person. There's a woman who has a very famous story about this. Her name is Eileen Collins. She was the first female commander of a space shuttle mission for the United States of America.
Mm.
She was a person who didn't like math and didn't think she was good in math and avoided taking math, but she wanted to be a pilot and ultimately an astronaut. And when she got to college, she discovered she needed to master calculus, something she had not mastered in high school. Because her desire to be a pilot and astronaut was so strong, she just told herself, I am going to master this. And she did. How
Mm.
much easier would it have been for her if she had never had that poor attitude toward math? And how many potential astronauts have we lost? Because a lot of people will say, oh, I need math. I'm not a math person. Okay, astronaut's not for me. Let me go in another direction.
Right.
So part of my goal with children is to instill an attitude that is positive toward hearing the word math, which I think carries into their education, which then makes sure that every door is remaining open to them so they're not artificially constrained from doing something that they might otherwise really have enjoyed doing.
Which is exactly our goal, I think, for all children to open up as many opportunities and possibilities as possible. Cindy, thank you so much for joining us today. It has been such a pleasure, and we will put all the links to MoMath in today's show notes so that people can find you wherever
Thank,
they are.
thank you so much. It's been a pleasure talking with you as well.